Bitcoin. Fascinating, is it? What if I tell you you can predict the Bitcoin's next day's price if it goes down or goes up using machine learning? So in today's video, we're just going to do that. So now let's get into it. Okay, so welcome to the tutorial section of this video. So now what we'll be doing is we'll be taking like data from Wikipedia and pair it with some Bitcoin pricing in order to predict tomorrow's values. Obviously, any model, whichever model you give it, it will not predict right sentiment based on just historical data. Current affairs should be some kind of relative to it, right? So now for that, we will be first taking some data from Wikipedia, and then what we will do is code it out in some other ways. Okay. So now what will we do is go to Colab and open a new notebook. Wait a second. Okay, so now we'll be requiring something called as MW. This is kind of a web scraper, but it is not actually a web scraper. It uses like something called as site. It scans the site. We'll be scanning Wikipedia here, and we'll be searching for the term Wikipedia, the specific Bitcoin page. Okay, so now we'll move on to the tutorial itself. Firstly, what we'll be needing is the MW client. It is not actually installed, although it might be installed in this. Oh wait a second. This is Gemini. I have to disable this. Okay, AI assistant. I don't know who's the generative AI assistant. Okay, let's drag it to the second screen. Yeah. Okay. Now we'll be installing the MW client first, and then we'll be using time in order to generate a time series data. I'll tell you why. Okay. So now with install, not install, it's install MW and simply client. That's it. Then we'll import MW client. Then we will import time. Now, in the MW client, we'll set up a site, and in that site, we'll set up a page. So in this case, Wikipedia is the site, and Bitcoin is the specific page we are trying to search. So, site will be equal to MW client dot site, and we'll just give it in two quotes. So Wikipedia's URL is en.wikipedia.org. I hope that's correct. As I remember, that's the URL. So we'll be using page. So in the site, we will scan the pages. In those pages, we'll hash out the Bitcoin. Okay, that's it. So now we have Wikipedia site and page Bitcoin from that site. Now we'll just run this. Let the instance connect. If I run this now, and again go to the second screen, that should run fine. Now it will select the site and the page, as I said. Let it run. Till then we'll do something as revs. What are revs? It is a revision of those pages. So we will do list of those revisions. So page.revisions. Okay, and it's a function, I guess. I don't know. I run this, and this S should be capital. Yep, that should run. And Now it should be defined. Okay, so revs are running. So if I do revs of 0, I will get a revision ID as well as a parent ID, some minors, then timestamps and all. Let's see, it should run for a while, like 30 to 40 seconds. I don't know, because it has to do every revision. And we are doing this in a list format because we have to cut out the dataset for now. Why? If I do all training on all the dataset, it will take me a while. We are talking about 3 to 4 hours. So no, I'm not gonna do that. We'll be just doing a normal thing. We'll be just cutting out the dataset to first 1000 revisions. Let's say, yeah, 1000 revisions are good. So till then, after the data after the 1000 will be scrapped for us. But in order to train a real world model, you just have to use all the data. It's just for the tutorial purpose that I am scrapping out the data, but doesn't have to. Okay, so here it's actually running. So let's hope it runs really quick. Till then, we will do revs equal to and sort it out. We will sort the revs with the key as lambda function. Blah. Rev in rev of timestamp. So it will be sorted in timestamp manner. Run this as also. Okay, it's been 2 minutes. I don't know why it is taking time, but it ran. And what did I do wrong? Okay, the timestamp. This should run fine. Okay, and now if we check the revs of 0, the rev ID should be different. See, this rev ID is different than this one because it is now sorted in increasing order of the timestamp. Like the oldest will be at the first, and then the newest next. Okay, get the point. Okay, so now we'll be using sentiment analysis pipeline from the transformers in order to scrape some information in order to do some sentiment analysis over that Wikipedia's data. Now, what we'll do is from transformers, we'll import pipeline, and now we'll define the sentiment pipeline as pipeline of, this is a function, and sentiment analysis. Typos, make sure you clear those, or you might get stuck into error thinking like you did something wrong in the logic, but it's always a typo. Okay, so now we will define a function to find the sentiment of a comment on that page. I will just tell you the little things. Okay, so we will pass the text. It's just not our worry about what text is right now, but we'll be passing the text from the revisions. Just keep that in mind. Okay, so from text, we will be sent equals to sentiment. Sent is also sentiment, right? Sentiment pipeline. And what we will do is we will pass the text in first 250 characters of 0x. Okay, and then we will do a score equals to cent of score. So now if cent, since label is negative, the score actually went down. Okay, so we'll just multiply it by -1. Label equals, this should be negative. So if the price got down, we'll just multiply that score with -1. So it will just differentiate between the positive and negative. Now score multiply equals to -1. Now we will just return the score at last. Where do we return? LSTM. Okay, this should run fine. Till then, what we will do, we will do edits to like store in the CSV file. So edits will be an empty dictionary for now. So for first of all, we will just let that pipeline run. It will download some things and all. Okay, so we will do revs equals to revs till first 1000. We'll just scrap out the rest of the data. You already know why. Okay, so for rev in revs, for each rev in the revision, the date will be equal to time dot str time, and the time format that I want to pass is something kind of, let's do year, then month, then day. That should be day. Okay, and now what we will do is ref of timestamp. So we will just extract that timestamp into this date format from the revisions timestamp. Okay, and now if the date is not in the edits, we will just append it. Okay, that should do it. The edits of date, to that specific date, we will store a dictionary. So date sentiment equals to list, and edit count will be set to 0. Okay, this should do it. And this is not sentiment, this is sentiments actually. Now the edits of date and the edit count will be plus equal to 1. We'll just increment it, and the comment will be equal to revision dot get. We will get the comment from that page. This should be a small c, comment of that page, and pass it to the empty dictionary. Empty string, by the way. Okay. Now what we will do, we will call the function sentiment analysis to get the sentiment of this comment, a particular comment that we got from the Bitcoin, like Bitcoin page on the Wikipedia. So now we will do edits equals to, edits of date, and the sentiments. Now we will save the sentiments where in this edits, in the dates sentiment of that particular date, we will append the sentiment analysis that our transformer did here. Okay, the pipeline, sentiment analysis pipeline actually. Okay, so I'll just quickly get through this and pass comment here. That should okay. And what did we do wrong? Find sentiment. It's actually good. Why is it giving squiggly lines? I don't know. Okay, yep, looks fine. Now it will run for a while. Let's just let me tell you. Now what we will do is get this mean of this comment and all. Okay, so for each key in the edit, what we'll do is, if the length of the sentiments is greater than 0, what we will do is set it as a mean, and then we will just append the length of the sentiment. For that, we have a function. I'll just paste it here. So from statistics, we will just import the mean. Then for key in every edit, what we will do, a length of the specific key's sentiment is greater than 0. We will just do its mean, and then again the negative sentiment will be sent as length of s for s in every key's sentiment if the sentiment is less than 0. And I will just divide it by length of edits and then key sentiment. Sorry, edit sentiment of that key in edits. This is actually kind of like hard to explain because there are two square brackets and all, but it's okay. And lastly, if it is less than 0, we just set it to 0. That's it. Okay, so now lastly we will just delete the sentiment of that particular key in edits. That's how we do it. Sentiments in a particular key of edits. You run this, it should run fine. And now we will import pandas. And now we will do edit df equals to pd dot data frame, and we will pass the dictionary. So from the edits, and the orient will be index. And run this, and now do edit df. Okay, what happened? Oh, the F should be large, or the capital one. I do edit df. It should give me this, yeah. Yep. It should give me a data frame with edit count, then sentiment, then negative sentiment. Okay. So now we will do edits df dot index will be equal to pd dot to datetime edits dot should be e edits dot df dot index, and this should run fine. Okay, dictionary object has nothing as df. Interesting. Edits df pd dot to datetime edits dot df dot x should be underscore. That's what happened. Okay. Now we will import datetime. So import datetime from datetime. This is confusing, but it's okay. So we will import datetime from datetime, then do dates equals to pd dot date range. We will do start equals to, let's say, from 2009, then 03, then 08, then we will end it with datetime dot today. So we will get data from the starting of Bitcoin till today. If I run this, it should run fine. Okay, done. So now if I do edits df equals to edits df and reindex it to dates and do the fill value is equal to 0. It should give me the date as the index. Then the edits df will be equal to set will be equal to as data frame but with date set as the index. Okay, so now that's fine. So now let's do rolling edits. So rolling equals to edits df dot rolling will do 30 and the minimum periods will be equal to 30 and we will do dot mean. Okay, so rolling will be equal to rolling dot drop NA. So we'll just drop the values and lastly if we do rolling it should give us something like this. Okay, that's good. Now Control C, we'll just save it as a CSV. Okay, now here it's actually good. Okay, so once we save that file into Wikipedia edits.csv, what we will do is just go here. It should pop up here. Yep. Now let me just rename it for the sake of this tutorial. We just created a new notebook, that's why it doesn't have a name. So Bitcoin price prediction. Okay, it should do it. Now this file is here. Okay, what I will do, I'll just clear all these code cells and let's not do that. So for you should use another notebook, another Colab notebook in order to do this, but you can just work on the same notebook. I'll just work on the same notebook for now. Okay, so here we need a separate file. We need this file called btc.csv, and now this file actually contains all the Bitcoin and all that data. Okay, now if I close this, and what we need to do is again we are going to use, if I go down, let me add some code cells. Okay, so here we will go importing some kind of modules for the finance things. So here we will use Y finance and then we will work on finance. Okay, now first what we will do, we will import some dependencies. Here I will use Y finance as YF, and pandas is already imported, so we'll just run it. Okay, so no model name Y finance. It's okay, we can just pip install it. I actually accidentally ran it. So exclamation pip install Y finance. Okay, now this should work fine. It was a typo, not a dependency issues. Okay, that should do it still. Let's wait. And just cancel this. The runtime disconnected, and that means the file is gone. Yep, good stuff. Thank God I just didn't I didn't clear all the things. Thank God. Okay. So that's one thing you should take care of, because obviously the runtime of Google Colab might disconnect at any time. It may disconnect in 30 minutes or it may disconnect in 2 minutes. I don't know why, but yeah, it happens. So now we will just wait till this thing just gives it time and I'll get back to you. So till this thing runs above here, what we will do is just we imported the dependency already. Now we will just read some CSV files using pandas. So obviously I have to again upload the btc.csv in Google Colab, but the runtime is still running. That's why, yeah, the code cells are still running. That's why I'm not uploading it right now. Although let's just write code to import it. So we'll do btc equals to pd.csv. Sorry, it's read CSV. And what we'll do is btc.csv. Okay. And then we'll just run it, and it should give us an error. How much long this is going to take? I hope not much. Okay, it is started to run, but okay. So yeah, so if we just look at BTC, and although it will give error for now, let's just wait here. Actually running, it's taking a lot of time, but it should work. Okay, and the cell should have already finish doing that stuff. And these cells are normal, so that's nothing. My laptop is running actually on a high fan speed. I don't know why. Although I'm running Google. Let's just wait for this cell to run, and let's get back to the project. I can't even show you guys what to do next, because I have to first look at the data frame and then we can just work on the values. You know what I mean? Okay, so for now, I'll just tell you what things are we going to take in action in order to work on this project. So now we will be importing random forest classifier, and we will be classifying whether the tomorrow's Bitcoin price will go down or go up. Okay, I think that should make sense. Yep, that's running. It is also running. And yeah, the btc.csv gave us an error. This time, I'll just download the file. No, it is just 150 KB, so yeah. My internet is not that much slow, but okay. Video edits, and then we'll just upload the btc.csv. Okay, yeah, good to go. Now, if I run this again, it should run fine, and if I run this again, it should run fine. And as you see, we have the data frame. Okay, so this data frame has two columns. I can see the dividends and stock splits, which have 0, 0 everywhere. So we can just first take care of that. But first, what you have to do is set state as the index. That's the first part we have to do. That's the crucial part to in the time series data. So So btc dot, let's do index equals to pd dot to date time, then btc dot index, and that should do it. Yep. If I do btc, don't tell me it again disconnected. Nope. Thank God. Okay, so that's btc. That's yeah, quite good one. Now let's do, okay, wait, I did something wrong. BTC's date column should be the index. Yep, that makes sense now. Okay, so now we will just do the last, like delete last two columns. So BTC of dividends, and we will do delete BTC of stock splits. These columns need to go. This is capital. Okay. It should not get, okay. I ran it again, that's why. Yeah. That should run fine, although we can just do Ctrl-Z. Now, if I go here and say btc.columns equals to list of c.low for c in btc.columns, yeah, that makes sense, and then btc.plot line, we will do y equals to close, and then do use index equal to 2. That should use the index as one of the parameters. And did we import the necessary things? I hope we did. White underscore, okay. Yeah. So now I think we can just run this. Let me like take care of this. I don't know what happened. This should be like gone by now. It is not. Okay, it's gone. So now we will just import the Wikipedia data that we created. So we will do wiki equals to pd.read csv, and we will do Wikipedia edits.csv. We will do index equals 0. Sorry, the index call equals 0, and we will do parse dates, and we will pass them. So we will do 2. Now if we do wiki and run it, as you can see, we have the data frame. Now we have to merge wiki with the Bitcoin. So for that, we are going to use the merge function. So btc equals to btc.merge. We will merge the wiki and do left index equals to, and also the right index. So it will keep all the indexes. So write index equals 2 as well. Okay, and that should run fine. So BTC of tomorrow now. Tomorrow, if I can spell it right, will be equal to BTC dot close, not dot close, but yeah, BTC close dot shift to -1. Okay, and now the BTC's target will be equal to, let's do BTC dot it's again tomorrow if greater than BTC's close, and we will do as type 90. So if the tomorrow's value is greater than today's close, it will just set the target as 1, that is true, and it will just give it to this typecast and do it enter. Okay, so now if we say BTC and now let's just check, yeah, the target values are here. Okay, so now what we will do is train ensemble model, we will just train a random forest classifier in order to predict the model. So what we will do, here I have a list of predictors, the features that we are going to use in order to predict the value. But firstly, let's just do from sklearn dot ensemble, we'll import random forest classifier. Okay, I will do model equal to random forest classifier and do n estimators equals to, let's say, 100. This should be here. Next one, what we will do is minimum sample split equals to 50, and then again random state as 42. Okay, and by the way, if you remember, sorry, what happened? Okay, the samples split is there. Okay, so if you wonder why I write kind of like this and not in one line, I am a PyTorch video, that's all. That's not a flex, but yeah, in PyTorch we write every parameter that we pass to the machine learning model, every half a parameter, we write it in the next line because it's just better to write like that way. Okay, so yeah, now what we will do is define a list of predictors, as I said, and then we will do model. But firstly, we will just do a training data. So let's do train equals to BTC dot alloc, and let's do first. Okay, we'll copy this down and do test and move this colon to the last position. Okay, that should be okay. So now we will do model dot fit, and we will fit the model to the train data predictors. Okay, and let's do train of target. Okay, yeah, that's it. Now fire on this. It should run fine. Now what we will do, so we will just identify how much it gave us, like in terms of precision score or something like accuracy score. We'll just import precision score form. Okay, so from scale dot matrix, we will import precision score. Okay, now we will do threads equals to model dot predict. We will predict the test data, and then we will do threads equals to pd dot series, element in series, and threads comma index equals to test dot index. And now what does it give me? Like, alright, maybe it should be precision score. Okay, yeah, so now precision score equals to, sorry, we just pass it the test of target as the actual value and the threads as the prediction. And let's see how much we got. Okay, what happened? Precision underscore score. Okay. What? Okay, the S is capital. Okay, so as you can see, it is actually it is actually 45% that we did in terms of first 1000 revisions. So if we like increase the data, this percentage might increase in a good way, or it might get overfitted, we don't know. But for 1000 revisions, this is actually a good score. 45%, 45.69 to be exact. Yeah, it's a good score. And if we just take a look at the predictions, zeros and ones and all. That's it. So yeah, that's it, the tutorial part of this video. You can like make this model into a end-to-end prediction. You can just make a serverless Flask API to just serve the model in backend. That's it. And that's how you predict any stock market values, friends. Any stock, any cryptocurrency, any fiat currency, doesn't matter. Only use this strategy and use a large data set. Although we used a small data set just for tutorial purpose, we will be using a large data set in real world problems. And also use kind of like a different model. What if we use some kind of neural network like LSTM, bidirectional neural networks, or we just use something like XGBoost or CapBoost? I'll keep it to you. Okay, so now search these models, how they work, how they do, and how they perform against the same data that we have performed. Okay, so that's it from my side. It's Atharo from Pi Analytics. Bye-bye.